The first step in the 5-step methodology is to define sustainability proposal, so its size and time scale. So let's think what we are trying to achieve. How else we can look at sustainable development? We can say it is one that provides needed products and services in ways that minimize the drain on resources, is legal, economically viable, and acceptable to all stakeholders. Let's look at an example. So the statement suggests that the half of all new cars must be electric by 2030 to meet European emission targets. The statement is our articulation. The icon is on the right. Any articulation has objective, size, and timescale. In case of electric cars, we have objective to meet European emission targets, and size, half of all new cars, and the timescale. Here we have 9 years. In the 5-step methodology, after we have defined objective, we will need to identify stakeholders and their concerns. Stakeholder could be defined as anyone who is profiting from or affected by the proposal. In case of electric cars, this includes, among others, government, public, local communities, owners, manufacturers, lobbyists, and investors. So the third step is fact-finding. Here we look at the implication for resource-related and human-related factors. Imagine materials, energy, environment, legislation, economics, and society. So the fourth step, we need to form a judgment about the impacts on free capitals. And the fifth is a reflection. Let's look at the 4 remaining steps in the case of electric cars in more details. Let's start with social context, so stakeholders. Here is a possible list of the stakeholders and their concerns for our case. Fact-finding. We need to research facts about the articulation and stakeholder concerns. So, what are the resource demands? What environmental impacts? What social implications? In case of electric cars, what carbon footprint is coming from electricity grid? What is the carbon footprint of a grid electricity? What materials? How much lithium, cobalt? What about supply chain? Would consumers accept a higher price or limited range? We will use tools and data from Granta's EduPack to unpack these questions. We will use EcoAudit as a streamlined LCA with costing function, social impact audit tool, social, economic, and legal data from nations of the world, and database of materials and processes with environmental data and information on criticality and restricted substances. So this is how the information on materials and processes, regulations, is connected within the Sustainable Development Database. Batteries for modern electric cars and many other electronic devices are based on lithium-ion technology. Here are some of the most common ones. Here we can see why this type of battery is so popular. It has very good overall performance, in particular, specific energy. Specific energy is stored energy per mass, promoting range. The most important one is probably the lithium, nickel, manganese, cobalt. This has not so much lithium and cobalt in itself, but this translates to around half of all industrial use of both of these metals for batteries globally. So lithium-ion batteries perform much better than others, and they also don't contain lead or cadmium. Here you can see a chart made with Granta's EduPack, which shows how different batteries are performing in relation to specific power and specific energy. So specific power is power per mass, which promotes acceleration, and specific energy, which is stored energy per mass, which promotes range. Another important consideration is battery space. So here, a chart which shows different types of batteries in terms of their energy density, with stored energy per volume. And this aids to design and comfort. So lithium is the best, but it is on the US and the European list of critical elements, and lithium batteries usually contain cobalt, which is critical material in Europe and in the US as well. Let's zoom in on cobalt. If we look at Granta's EduPack and its elements database, the Sustainable Development Edition, we can browse for cobalt record. The extract of this record provides useful information on main mining areas, on criticality status, and of elements, among other data. Predominantly, production is happening in the Democratic Republic of Congo, a country with many social hotspots, you can call it the social issues with ongoing conflict and the child labor instances. Nations of the World database provides detailed socioeconomic data. Getting back to our 5-step method, we now need criteria to access the implication of these facts. Here again, our framework of free capitals will help us. So, impact on free capitals. A very short possible assessment: natural capital, objective not achieved, possible if grid is decarbonized. Manufactured capital, supply chain for lithium and cobalt are in doubt, but we can expand production. There are also social investments opportunities and human and social capital. There are aspects of range anxiety that was possibly not met yet, but with battery development it could be overcome. With all the facts at our disposal here, we have outlined only a few. But we can think about what lay behind the proposal, what are its strengths and weaknesses, what about long-term versus short-term gain, could the objective be achieved in any other way? In the short term, objective cannot be achieved. Infrastructure, material supply, battery recycling are doubtful in the short term, but in the medium term, we can decarbonize the national grid or create recycling infrastructure. And the long term, we probably can rethink or redefine the car use.